Welcome to aminacademy.com. In Laplace transform, let us do some Laplace transform of some basic functions. Look at this example. Laplace transform of cos 80. By definition, we know that Laplace transform of some function equal integral 0 to infinity e power minus st into that function, that is cos of 80 dt, where s is greater than 0. Now let us integrate by parts. Here e power minus st is the first function and cos 80 is the second function. That is integral of uv equal first function, integral of second, minus integral of differential of first and integral of the second. Regarding this, we'll do the integration of e power minus st into cos 80 equal first function, that is e power minus st into integral of second. Cos 80 integration is sine 80 over a minus integral of differential of first. E power minus st differentiation is minus s into e power minus st into integral of cos 80 is sine 80 over a. Here 0 to infinity. Here we'll find 0 to infinity here. Now if you substitute infinity for the value of t, it becomes e power minus s into infinity, that is e power minus infinity. It become 0 and minus, if you put the value of t as 0, e power 0 is 1, but into sine 0 is 0. So first part become 0. Next here minus into minus is plus and s minus a take out, therefore plus s over a integral 0 to infinity e power minus st into sine 80 dt. Now we'll integrate by parts one more time of e power minus st into sine 80 here, that is s over a here. First function is e power minus st, that is first function, into integral of the second. Cos 80 integration is minus sine 80 integration is minus cos 80 over a minus integral of differential of first e power minus st differentiation is minus s into e power minus st into integral of sine 80 is minus of cos 80 over a into dt, 0 to infinity. This whole bracket now, which is equal s over a. We are giving the limits of 0 to infinity here. Infinity, if you substitute for e power minus st, it becomes 0. That is but this is minus also take out. No, here 0. Cos infinity, that is 0, becomes minus. Here the one more minus is there, so it becomes plus. If you substitute 0, e power minus st, that is e power 0 is 1, and cos 0 is also 1, so it becomes 1 over a then it becomes minus into minus plus into minus is minus integral of we'll take before we have to take s over a here, minus of s over a integral of e power minus st into cos of at dt. Here already we started with the integration of e power minus st into cos at, which is nothing but Laplace transformation of cos at. Now we'll rewrite this Laplace transformation of cos of at equal here s minus a 1 by a minus s over a and Laplace transformation of cos at. Now we open the bracket, we distribute s over a, both s over a square minus s square over a square and into Laplace transformation of cos of at. Now we have both side Laplace transformation of cos at, so we collect one side, that is Laplace transformation of cos of at minus becomes plus s square over a square into Laplace transformation of cos at equal s over a square. Now factor take out as a cos at, Laplace transformation of cos at into 1 plus a square over a square equal s over a square. Now therefore Laplace transformation of cos of at equal s over a square over 1 plus a square over a square, which is equal s over a square, take LCM as a square here, into a square plus a square, then here a square and a square cut, then we can write Laplace transformation of cos of at equal s over a square plus a square. So we got Laplace transformation of cos of at equal s over a square plus a square. We have done. Now this Laplace transformation of cos at we can do in method, one more method, like we'll change the color. Here let Laplace transformation of cos of at plus I imaginary I sin at, which is equal to Laplace transformation of by Euler's formula e power I at. here not Euler's formula, it is de Moivre's theorem. Now here we know that Laplace transformation of e power iat equal 1 over s minus ia. Now write 1 over s minus ia and multiply up and down as conjugate of that one, s plus ia over s plus ia. Then numerator is s plus ia and denominator is s square minus ia whole square, that is s square. I square is minus 1, that is s square plus a square. Now comparing the real part both side, we get here the real part of the Laplace transformation of cos at plus I sin at is Laplace transformation of cos of at. Here the real part is s over a square plus a square. You can write a square plus a square. In order we can write here Laplace transformation of cos of at equal s over a square plus a square. We got the same result. We have done. Please subscribe our YouTube channel.